All right, we're going to look at the notes for Unit 5, Lesson 2, which include the ruler and segment addition postulates. So if you don't have these notes, hit pause right now and go print them, or you can write them on a piece of paper, but they are on It's Learning in the plans for Lesson 2. All right, I will go ahead and go through this question right here, which is the do now question from the day. And what we have here is an ACT question, and they love to do this type of question where they give you a formula like square root of A equals B, and they want you to substitute in something and then find the other thing based on that. Okay, so in this case, they told us B was 9. So we're going to say square root of A equals 9. And so basically they're saying, which one of these could you take the square root of and get 9, right? So we know square root of 3, square root of 18, square root of 81. We would take the square root of each one of these. And I think we can kind of all agree that the square root of 81 is, in fact, 9. And so C would be our answer. Okay? All right, so thinking about the actual notes that we're talking about and not just this do now question, right, was kind of out of left field. We begin by talking about the ruler postulate, which says that every point on a line can be paired with a real number. And so we're thinking about any line here, which we kind of know is comprised of an infinite number of points. So if we think about a line, we know really there's an infinite number of points along that line. And you can see what I'm talking about. There we go. An infinite number of points along that line, right? So I can always come in between, over and over and over again and get points. So we're saying every single point on that line can be paired with a real number. This makes a one-to-one correspondence, meaning every point has a number, every number has a point. Correspondence means relationship, sort of, between the points on the line and the real numbers. The real number that corresponds to a point is called the coordinate of the point. The coordinate of the point. And so we think about if we were to take a number line like this one, let me zoom out here, and like this one right here, and we were to put a ruler up to it, we would have a one-to-one correspondence, okay? Let me see if I can make that make sense to you. So if I were to create a line, I could measure any line given a ruler, right? So if I were to take this ruler and put it up against here, I would say, okay, well, it is 3/4 of an inch-ish. Obviously not exactly 3/4 of an inch, but that would be how I would measure it. So that's what we're talking about here is distance. And it turns out that I can find the distance with subtraction, which I think we can make sense of here. If I always said 0, 1, 2, 3, 4, and I put A here, and I put B here, and I asked you for the distance from A to B, well, you could easily count the distance. And remember, we count spaces, not points. So it would be 1, 2, 3. So my distance would be 3, right? Or I could take the coordinates of the points, which would be the number associated with the point. So B's coordinate is 4 and A's coordinate is 1. And I could subtract them. So 4 minus 1 in this case would be 3. So what I want to think here is, all right, well, I can just take the numbers and subtract them. Well, the problem is if I subtract A minus B, which in this case would be 1 minus 3, or excuse me, 1 minus 4. Well, 1 minus 4 is negative 3, but my distance is always positive. And so what I can do is I can actually use the absolute value to take 1 minus 4, right, and turn it into a positive 3. And so my formula looks like this. It looks like the absolute value of A minus B gives you the distance between 2 points on a number line or the length of a line segment. Okay? And we kind of want to note here that Notice how there's no line segment above this, and that's because this notation right here is for distance, right? So this is going to tell you the length of a B. It does not represent the name of the line segment. All right, so let's look at a couple of examples here for just measuring our segment lengths. So we know that we could just count, but we want to be able to also use our formula for when our numbers get huge and we can no longer count. So here's what our postulate says, our ruler postulate. It says that if I want to find the length of ST, then I can take the absolute value of the coordinate of S minus T, and that will give me my answer. Okay? Well, the coordinate for S is -8, and here I'll do this color coordinate here. So there we go. S is -8 minus the coordinate of T, which is -3. So I'm just finding my coordinates here, and then I'm just going to do some arithmetic. So I want to think about minus and negative being a plus sign. So I'm going to have the absolute value of -8 plus 3, -8 plus 3, and then -8 plus 3 is the absolute value of -5. And then I take the absolute value of -5, and I get +5. Remember, the absolute value of a number is that number's distance from 0 on the number line. You may remember it as it makes it positive, and that is true. But the reason it's true is because it's just giving you a distance from the number line, right? So our answer here would be 5. And we can actually check 5 to make sure it works. So I would say 1, 2, 3, 4, 5. And so my distance from S to T is 5, or the length of my line segment ST is 5. Another way to think about it. Okay, so let's look at the next 3. We're looking at VU, so from V to U. So I'm going to take the absolute value of V minus U. That's what the ruler postulate says here, that I can find the distance by taking the absolute value of the difference. And so I need to find the coordinate. The coordinate for V is 9. And the coordinate for U is 3. And then I need to do the arithmetic. So I need to subtract first. 9 minus 3 is the absolute value of 6. And the distance of 6 from 0 on the number line is 6. So we can see here, if we wanted to check 6 from U to V, I would say that's 1, 2, 3, 4, 5, 6. And so this length right here would be 6. If you're watching this for the first time, you might want to pause the video now to try V and T. To try C and D on your own, and then replay to make sure you get the right answer. Okay. All right. So TU, looking at the absolute value of T minus U. So the coordinate of T is the absolute value of -3 minus the coordinate of U, which is +3. And if I subtract -3 minus 3, then I get the absolute value of -6, and the absolute value of -6 is +6, right? And again, you could check this on the number line, if you so desire, by just counting from T to U. So 1, 2, 3, 4, 5, 6. I did that opposite, but 1, 2, 3, 4, 5, 6. You can sort of see it works either way. And so the length from T to U is in fact 6. All right, VT. We have the coordinate of V, which is 9, minus, oh, I'm just skipping right ahead here. Let me write the letters out. So the absolute value of V minus T. So the coordinate for V is 9, and the coordinate for T is negative 3. And again, we're looking at, sorry, you can't see that, 9 minus negative 3. So this minus and negative is going to become a plus sign. And then I can add 9 plus 3 to get 12. And then the distance from 0 to 12 is just positive 12. Okay. And we can check that from V to T, from V to T. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So from all of this, we're going to get 12. Okay, I'm actually going to post a second video because I think this will get lengthy if I try to put them all together on one video. So that is the ruler postulate, and find the next video for the segment addition postulate. I hope that helped.